Guys, welcome to another video. So today we're going to be working on statistics, and the topic we're looking at is statistical distribution. Before we start, here's a prior knowledge check. So what I'll allow you guys to do is pause the video and have a go at this. So you need to be able to understand and use probability distribution. A random variable is a variable whose value depends on the outcome of a random event. So for example, when we roll a 5 on a die, the number of 6s rolled would be a random variable. The range of values the random variable can take is called a sample space and is often drawn as a table. A discrete random variable can only take a certain countable numerical values. So for example, the number of people has to be a whole number. So in this chapter, we'll be focusing on discrete random variable. And next year, on the stats, you look at the continuous random variable or continuous distribution. So today we're just focusing on just simply discrete. So these are the values which can only take certain numerical value, each of which can be assigned a probability. So for example, number of times a 1 is rolled when rolling a dice 10 times. It can only take certain numerical value, and each one can be assigned a probability. So for example, of the random variable, let's say x is a score when a fair dice is rolled. So there are 6 outcomes, and on a fair die, each outcome is equally likely to come up. So it's 1 in 6. The letter X represents the event we are considering and includes all possible outcomes. The lower row means the probability of observation being equal to X. In this case, the probability of the score when a fair dice is rolled being equal to X, the top row. So if all probabilities are the same, we say these are discrete uniform distribution. So if you were to plot this on a graph, you simply just get a rectangular shape. Okay, so on this one, we're talking about 3 fair coins that are tossed. We want to write down all possible outcomes when 3 coins are tossed. So first of all, you could get head, 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 all 3 times. We could get head, tail, head, 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 tail, and so on. A random variable x is defined as the number of heads when 3 coins are tossed. First, we want to write the probability distribution of x as a table, and then we want to write a probability mass function. So there are 4 possibilities for the number of heads. You could get no head, head once, twice, or all 3 times. So as a table, it would look something like this. So all I need you to do is pause the video and see if you could copy and complete the table, because you could see the probability how often each one is likely to come. So there are only one outcome of getting no head, which is getting tail 3 times, and it's out of 8. So that probability here will be 1 over 8. This one will be 3 over 8, because there are 3 possible ways of getting only one head. For example, you could get head, tail, tail, or tail, head, tail, or tail, tail, head. So there are 3 ways. So it's 3 out of 8. Same for getting it twice, 3 out of 8. And getting head all 3 times, there's only 1. So it's 1 out of 8. And what you need to do here is remember that X represents the event we are considering and includes all possible outcomes. So now we're going to look at probability mass function, which summarizes the probabilities and event which take those values. So probability capital X equal to X. We use a curly bracket like this, and getting 8 Well, these are the x values that will give us an 8. 0 and 3. 3, 8. Well, these are the x value 1 and 2. Now, this one, you always would have a 0, and we say otherwise. So 0 would imply impossible for anything else. So this is called probability mass function. And what you'll notice here is if we were to add up all of these probability, it must equal to 1, because we know the total probability is 1, because we exhausted all the events. So another way we could write this using sigma. Notice the capital letter sigma in maths, it means the sum. So we're summing the probability of x equal to x, which equals to 1 for all values of x. So on this one, we're going to be looking at a biased four-sided dice with the faces number 1, 2, 3, 4. And the number on the bottom face is modeled as a random variable x. So we are given that probability x equal to x is equal to k over x. We're going to find the value of k, give the probability distribution of x in the table form. So we're told that the probability of capital X equal to x is k over x. So think about this. You're being told the probability of the number being rolled is equal to k divided by that number. And that's what the x at the bottom. So there are 4 possible outcomes for this die. 1, 2, 3, and 4. Remember that since all outcomes are represented, the probability should always add up to 1. So if we do a table, 1, 2, 3, and 4, we are told is k over x. So for the first one, it's going to be k over 1, k over 2, k over 3, and k over 4. So if we solve it for k, and we know we need to add all of these up, and it's equal to 1. So it's just a matter of simple algebra. Here the common denominator will be 12. So if we times everything by 12, we group the like terms, and that would give us the k value if we divide by 25. So k is equal to 12 over 25. Okay, so now we know the k value. We could work each one of these out, simply replacing k with 12 over 25. And here's our answer to part B. Now part C says find the probability that x greater than 2. For part 2 of that question, we want to find the between 1 and 4, not inclusive. And part 3, x greater than 4. So let's look at probability of x greater than 2. Well, if it's greater than 2, you're only looking at the observation of 3 and 4. If you add these up, will give you 7 over 25. So for between 1 and 4, well, 1 and 4 are not inclusive, so it's just 2 and 3, 10 over 25. Greater than 4, or 10 over 25, if you simplify as 2 over 5. X greater than 4, so you're saying the probability of the random observation is greater than 4 here, which is impossible, so it's equal to 0. So here we're told the spinner is spun until it lands on red, or has been spun for 4 times in total. We asked to find the probability distribution of the random variable s, the number of times the spinner is spun. So the total time the spinner is spun is 4 times. So 1, 2, 3, 4, and then probability s equal to s. Well, probability s equal to 1 is that probability the spinner of spin is 1. So for example, we get red on the first spin. So if you get red on the first spin, you could simply stop, because it says the spinner below is spun until it lands on red. And the chance of that is 2/5. The 5 section and the red it represent 2 section. So that's 2/5. Probability S equals to 2. So that says that the probability the number of spin is 2. So i.e. we get red on the second spin. So if we get red on the second spin, that means we got blue on the first spin. Okay, so it's blue and then red. So on probability, to work out blue and red, the chance of blue is 3/5 and means to multiply 2/5, which is the red, which will be 6/25. Okay, so why don't you guys pause the video and then you have a go at 3 and 4. Okay, so probability S equal to 3, so that means getting a red the third time, so that means you got blue the first 2 times, so blue times red, so that'll give us 18/125, and probability S equals to 4, that means you got blue the first 3 times and the red the 4th time, so that'll be 1 minus all of this, or you could do blue times blue times blue times red. Either way it's fine, and the end result should be 27/125. Okay, so now we're going to move on and look at the binomial distribution. So the binomial distribution can be used to model the number of times a trial is successful. So Gary is playing chess against Nigel and has a chance 2/3 of winning each game. If they play 5 games, what is the probability of Gary winning exactly 3? So how many ways can Gary win 3? So these are all the possible outcomes. There are 10 in total. So the probability the first combination listed will be calculated will Gary win, Gary win, Gary win, Nigel lose, Nigel lose. So Gary wins the first 3 games and Nigel wins the last 2. All the other combinations will give you the same answer because you're multiplying this. It doesn't matter which order you multiply. So the second one, if you do Gary win, Nigel win, Gary win, Gary win, Nigel win, you're just multiplying these set of numbers. And since under multiplication, we said these are commutative, it doesn't matter which order you're doing it, you're going to get the same result. So therefore, the complete calculation would be 2/3 cubed, because that could happen 3 ways, times 1/3 squared, and you're adding that 10 times, because you could say this, or this, or this, or this 10 times, which is another way of saying just times it by 10. So the end result will be 10 times 2/3 cubed times 1/3 squared. So to give us the answer 0.329. So how many ways can Gary win? 3 ways. Well, there's a chance of Gary winning 3 games out of 5 is 32.9% chance. Okay, so you guys seen how to expand brackets or binomial expansion in pure maths. So all I need you to do is pause the video and find the term containing x cubed in the following expansion, x plus y to the power of 5. So you could use the formula book in pure maths, and you know, because we start at 5 and we're choosing 3, 5 choose 3, x cubed y squared, so that will be just 10 x cubed y squared. So if the probability of Gary winning a chess match is 2/3, find the probability of him winning exactly 3 games out of 5. We could represent it like this. So our x could represent Gary winning and our y represent Gary not winning. So you can see how this is related to what we've learned in binomial expansion. Okay, so we have our 10, we have our x cubed and 2/3 cubed, we have our y and a third, or y squared and a third squared. So these equations are essentially the same. So in this section, we're going to look at using binomial distribution for calculating probabilities. So to use the binomial distribution, a number of conditions must be met. There must be a fixed number of trials. Second, there are two possible outcomes. So we need to think of them as success or failure. So that's when some students get confused when they talk about rolling a die. They say, oh, but sir, there's 6 outcomes. Remember, our x, the discrete random variable, is looking at a particular outcome. So if you think about success or failure, we could say we're focusing on getting a 5 on a die. So getting a 5 would be a success, and anything else would be failure. Okay, so we could set them as two possible outcomes. You either get 5 on a die, or you don't get a 5. So think about it like this. And the probability of success is the same each time. So it shouldn't be affected. The probability each time of getting a particular value or success in this case should be same each time. And finally, the trials are independent of each other. So the outcome of one trial should not affect the next trial. So if all these 4 conditions are met, then we will have a binomial distribution. So if we have x approximates to binomial number of trial n and then p. Okay, so x is the binomially distributed, that's what this bit is saying, and number of trials n, probability of success is p. Then if we have probability x equal to r, so this is saying what is the probability of getting r success trial? N choose r. There's a number of ways of choosing r success from n trials. The probability of success to the power of r, the probability of failure to the power of n minus r. So what you should notice here is that r plus n minus r should always equal to n, because that's the total number of trials. Okay, this formula is given in the formula booklet in the section. So let's go back to our problem of Gary playing chess against Nigel. Using the notation above, we could represent this in this form. So straight away, when you get a worded question like that, you could write it like this. So x approximates to binomial, 5 trials, and success is 2/3. And we're interested in finding Gary winning exactly 3 games. So we could represent this as probability x equals to 3, 5 choose 3, 5 trials, and we want success 3 times, times by the success, which is 2/3 to the power of 3, times by the failure to the power of 2. So now if you calculate this, we get the same result as what we did before. So we get 0.329. Okay, so let's look at this example here. We're told x approximates to binomial distribution of 12 trials and a 1/6 of a success. So first, we want to find the probability of x equal to 2, probability x equal to 9, probability x less than or equal to 1. So the number of trials is 12. The success is a 6th. Here's the formula again. We're looking to find 2 success. So we simply substitute in r with 2, p with 1/6, and 1 minus p with 5/6. Now if you type this into your calculator, Okay, so once you calculate that, you get 0.296. So why don't you guys pause the video and have a go at part B. Okay, so if we look at part B, we substitute in the values, we're calculating, we get this very small chance, 0.000000126. So you kind of expect that because you're saying, getting success 9 times, exactly 9 times out of 12 trials. And look at the chance of success is the sixth. So one expects it to be a very small chance. Okay, so let's look at the inequality. So this time we're told probability x less than or equal to 1. If it's less than or equal to 1, that can be represented as probability x equal to 0 or probability x equal to 1. So we simply add them together. So you work out probability x equal to 0. So here you're getting no success. So it's all failure. And remember, if you did 12 choose 0, you're going to get 1 anyway, so that doesn't really matter. So 5 over 6 to the power of 12. So all failure plus 1 success. So 12 choose 1. There shouldn't be that line there. It's just 12 choose 1 times by success, which is a sixth, times by failure, 5 over 6 to the power of 11. And you simply calculate this, and we get 0.381. Okay, so let's have a look at this example here. So it says here the probability the randomly chosen member of a reading group is left-handed is 0.15. And we've taken a random sample of 20 members of the group. Part A says suggest a suitable model for the random variable x, the number of members in the sample who are left-handed, and justify your choice. So we consider there to be two possibilities. You're either left-handed, in this case the left hand will be success, or you're right-handed, which will be the failure. A number of trial is fixed, as is the probability of success. We can also assume that each member of the sample is independent. Therefore, the suitable model would be a binomial distribution. So x approximates to a binomial distribution with number of trials 20 and probability of 0.15. Use your model to calculate the probability that exactly 7 sample members are left-handed, and part 2, less than 2 members are left-handed. So for the first question, we know number of trials is 20, probability of success is 0.15, r equal to 7. You substitute into the formula, and then you work that out. And that gives you the chance of exactly 7 people being left-handed out of 20. Okay, which is going to give a 1.6% chance. Okay, so the next part of the question, less than 2 people are left-handed. So that means R could be 0 or 1. Remember, it's less than, not less than or equal to. So probability x less than 2, x equal to 0, plus x equal to 1. So if we work out each one of these, so 0 would mean all failure, so everyone's right-handed, which is 0.85 to the power of 20, plus 1 person is left-handed out of 20. If we calculate this, it gives us 0.176, so 17.6. Okay, so that's less than 2 members are left-handed. Alright guys, so pause the video and have a go at this set of questions. Welcome back. Here are the answers. Okay guys, so it's the end of this video. There's going to be two parts to this chapter. So this is the end of part one, and there'll be another video coming up on part two. Now, in this part, I've shown you how to work this out manually. Type each one in the calculator. But next series, I'm going to show you how this can be done on the calculator. So you could just use your class Wiz calculator, or if you have a graphical calculator, the Casio CG50. If you want to get heads up, if you visit my website, tutorbedford.co.uk, there are section, there are link on how to use the calculator to work out binomial distribution, both binomial probability distribution and cumulative distribution, which is for next lesson. And there's a link for both types of calculator. So there's a link for the class Wiz scientific calculator, and there's another link for the Casio CG50, the graphical calculator. So that's just a heads up for next video. Anyway, stay safe. I'll see you next time.